All right, let's say you're staring down a massive investment decision. Millions of dollars are on the line. How in the world do you choose between two assets with totally different price tags and, completely different lifespans? Well, top firms use a surprisingly powerful tool for this exact problem, the equivalent annual cost, or EAC. It's this incredible method that just cuts right through the complexity and turns these really tough choices into clear, straightforward comparisons. So let's break down exactly how it works.
So let's frame this with a classic dilemma. You need a new machine. Option A is cheaper upfront, $105,000, but it's only going to last you 3 years. Option B, it's way more expensive, $175,000, but it's a run for a full 5 years. Now your gut might just scream, go for the cheaper one, but is that really the smartest long-term move? This is a textbook apples and oranges problem, and it's exactly what EAC was built to solve.
So here's our game plan for today. We're going to start with why this dilemma is so tricky. Then we'll really unpack the EAC framework and get into the formula. After that, we'll put it to the test with our two-machine problem, clarify how it's different from a similar concept called whole life cost, and then wrap up with some really important limitations you've got to keep in mind. Let's jump right in.
And look, this isn't just some academic exercise. Businesses face this kind of thing all the time. Think about a logistics company trying to decide between two models of trucks, or an IT department choosing new servers. Maybe a factory manager picking a whole new production line. In every single one of those cases, you're looking at different upfront costs and different lifespans. And just looking at the sticker price, that's a surefire recipe for a bad decision.
So what's the governing thought here? What's the solution? The core idea behind EAC is actually simple, but it is incredibly powerful. We're going to convert the entire lifetime cost of an asset into a single, consistent annual number. It's kind of like turning this lumpy, complicated cost structure into a smooth, predictable yearly price. And that is what finally lets us make a true apples-to-apples comparison.
Okay, so let's get into the framework itself. We're going to break down precisely what equivalent annual cost is and really see why it's so essential for any kind of smart financial planning. At its heart, EAC basically annualizes everything. It takes that big, scary upfront purchase price, it factors in all the maintenance and operating costs you're going to have, and it just spreads them evenly across each year of the asset's life. Honestly, the best way to think about it is like a subscription fee. Instead of one massive payment, EAC tells you the all-inclusive annual cost to have that asset working for you. And its uses are really strategic. I mean, the main one, of course, is comparing projects, just like our two machines. But it's also amazing for finding the optimal life of an asset. Think about it, right? As a machine gets older, maintenance costs start to creep up. You can use EAC to figure out the cost of keeping it for 3 years, then 4 years, then 5 years, and so on. At some point, those rising maintenance costs are going to make the EAC go up. The year with the absolute lowest EAC, that's your financially optimal time to replace it. It's also a fantastic tool for making those lease versus buy decisions with total clarity.
Now, before we even touch the formula, there's one critical ingredient we have to understand. It's the cost of capital, or what we call the discount rate. The definition can sound a little technical, but the concept is actually pretty simple. Think of it as the minimum score a project needs to get on a test in order to pass. It's the return you could be getting on your money if you invested it somewhere else. So any new project has to beat that rate to even be considered worthwhile. This rate is what lets us account for the time value of money, that simple, powerful fact that $1 today is worth more than $1 tomorrow.
All right, time to get under the hood and see how this thing actually works. We're going to walk through the formula itself, but don't worry, we're going to make this super straightforward.
Okay, here it is, the formula. I know, it looks a little intense at first glance, but let's just decode it really fast. The top part, the numerator, asset price times discount rate. That just gives us a simple annual cost of capital. Now, the more complicated looking part is the denominator on the bottom. That whole thing is basically just a fancy annuity factor, and its only job is to properly spread that cost over the asset's lifespan, that's the N, while accounting for the time value of money. But look, you don't need to memorize this. The easiest way to think about it is in 3 simple steps.
And here they are. Step 1, you calculate what I like to call the cost engine. That's just the asset price times your discount rate. Step 2, you calculate that annuity factor. That's the denominator we just saw, which handles the time and interest. Finally, step 3, you just divide step 1 by step 2. That's it. That process gives you the annualized capital cost, which is really the heavy lifting of the whole calculation.
Theory is one thing, but the real magic happens when you put it into action. So let's go back to our original dilemma and use EAC to solve our two-machine puzzle once and for all.
Okay, here's our data all laid out side by side. We've got machine A, lower upfront cost, shorter life, but higher maintenance. And machine B, much higher price tag, but it lasts longer and has lower maintenance. We're going to use the same cost of capital for both, 5%. We now have everything we need to find the true cost of each option.
So, for machine A, we run our three-step calculation on its $105,000 price tag. That gives us its annualized capital cost. Then, we just add the $11,000 in annual maintenance. So what's the grand total? The true equivalent annual cost for machine A comes out to $49,557. Let's hang on to that number.
And now for machine B. We take its much higher $175,000 cost, but we also factor in its longer 5-year life. We run it through the exact same calculation, and then we add its lower maintenance fee. The final EAC for machine B? It comes in at $48,921.
And here it is. This is the power of EAC in one simple chart. When you put them side by side, the answer is just undeniable. Machine B, even though it costs $70,000 more upfront, is actually cheaper on an annual basis. It saves you $636 every single year. This is just a perfect example of how relying on the sticker price alone can lead you to the completely wrong financial decision.
Now, this brings up a really common question, and it's a critical point we need to clarify. How is EAC different from something called whole life cost? They sound kind of similar, but they actually serve very different purposes.
So here's the key difference. EAC gives you that annualized subscription fee. It's your yearly cost, which is perfect for comparing different options. Whole life cost, on the other hand, gives you the total ticket price for the entire ride, from the day you buy it to the day you get rid of it. It's one giant number that captures every single cost over the full lifespan. Both are useful, for sure, but only EAC lets you make that clean, direct, apples-to-apples comparison between assets with different lifespans.
So we've seen just how powerful this tool can be. But, you know, a great analyst always knows the limits of their tools. So for our final section, let's talk about how to use EAC strategically and, just as importantly, what pitfalls you need to watch out for.
It is so important to remember that EAC is a model, not a crystal ball. Your result is only ever as good as your assumptions. That discount rate, it's an estimate, and it can change. Your forecast for maintenance costs, those can be unpredictable. And critically, this basic formula is purely financial. It won't tell you anything about strategic fit or environmental impact or how a new asset might affect your team's morale. EAC is an incredibly powerful financial guide, but it should never be your only guide.
But with those warnings in mind, its value is just immense. EAC forces a discipline of long-term thinking. It pushes you to look way beyond the sticker price and consider the full, true cost of ownership. It gives you a structured, logical method to standardize these incredibly complex decisions, empowering you to make choices that are genuinely informed and financially sound.
So you now have a brand new lens for looking at major investments. It's a way to cut through all the noise of upfront costs and see the true long-term financial picture. The question I really want to leave you with is this. In your next big decision, what hidden opportunities, what critical savings will this new perspective help you uncover?